on this your presence, right? Okay, today, with the grace and the blessing of Allah, that able to gather us here in this hall for one purpose, that is to learn or to listen to the journey of PhD, how do Dr. Mundzir reach his PhD at an early age, and within the time frame of his study, that's 6 semesters. So Dr. Mundzir Abdullah here. Yeah. So we're going to conduct this quite colloquial, meaning that quite informal. There's no much of a tight agenda, right? For which that we want participation, interactions from the audience. Okay. First, let me introduce first who are the people in front. Okay. Let me come from, so parents of Dr. Mundzir, the name is Dr. Abdullah Daud, and her mom, yeah, Zakia Ahmad. Dr. Abdullah Daud used to be our former docents or lecturers at Faculty of Geoinformation. Okay. Then we have the chairman of Dr. Mundzir's Viva. I think you all know quite well Professor Jalil, right? Since Dr. Mundzir is from physics, therefore there will be many physics professors here. So now, after that is Professor Noria Bide, supervisor of Dr. Mundzir. And of course, without the clearance of the important person in the Viva Bose, internal examiner, Mundzir could not pass the Viva. Right? So he is a kind of important person here. That is Dr. Yaakob. So this debut event is, we don't have precedent yet. So we come up with the idea because we got the youngest PhD holder, not only in the Faculty of Science, not only in the Department of Physics, not only in the Faculty of Science, not only in the faculty, not only in the UTM, but the nations. So I think we are much glad. So 23 years and 5 months. This is March. So therefore, we'd like to hear today, how do he get to this point, right? All right. So with that, first I'd like to call upon Prof. Noria Bide to tell a bit, all right? To tell a bit, who is Mundzir, okay? And how does his attitude, his manner, his behavior, in such a way that he able to complete his study on time. So, yeah. Okay, Noria said that who could understand Malay sikit-sikit? Alright, sikit-sikit, right? Okay, go ahead.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Okay, Assalamualaikum Puan, kepada Ibu Bapa Mundzir. Sepanjang pengetahuan saya, I think Mundzir is a genius boy. He's actually fast track student, even from the Form 5, Form 5. I rasa dia daripada sekolah menengah MRSM memang melompat, so that's why the youngest compared to their friends during their time. And also he got first class in AC, so and then he directly doing the PhD without doing the master. So that's why I think he is actually become the youngest student in PhD. But beside that, I think he not only the genius student that I know, but he's also very friendly, very often, and all is actually the student in the lab. At that time, I have about 30 PhD students in the room, and he become the leader of all. Meaning that everybody asks him to help, and he is very friendly, and he, I mean, don't say that, never say no. And he have everybody. So because of that, I think, because he got barakah, is it maybe? I don't know. So then I think he managed to do, and he got a lot of knowledge, a lot of experience, and I think I advise all the PhD students, if you don't, I mean, if you are in the rooms, so you have to share the knowledge and spend your time to explain to your friends, and also explain, I mean, helps you other friends to design or develop their system. So that's maybe everybody doa for him, and he is actually passed without any restriction. Okay, I think that's it. I want to do it. Thank you.
Thank you, Prof. Noria. Okay, meaning that what Prof. Noria mentioned, that Mundzir would like to share with others, right? That's the thing. Okay. I think it's true. Many times that I would advise my students in my research group, that I mentioned that in the beginning you need to write, you need to read, and then of course, in order for people to know what you'll be reading, you need to write, and then one more thing. This is about sharing. You need to share, and share. I think with these three attitudes, I think you all can fly, like what Mundzir has said. Okay. Next, why don't we call upon the chairman of the Viva, how he see that this Viva say for when Mundzir defends his thesis may differ from other that he has checked. So we call upon Prof. Jai.
Assalamualaikum warahmatullahi wabarakatuh. First, I would like to extend my sincere appreciation and congratulations to the parents of Dr. Mundzir, Dr. Abdullah, for being able to basically bring up a young guy to this level. I think, again, we should be thankful to the Almighty for such reason. Again, to the Dean of SPS, Deputy Dean, thank you very much, and the organizer for having this forum to discuss on the next possibility of having probably the youngest. I would also like to congratulate on the supervisor for being able to produce a candidate with a PhD at this level. Now allow me to see. Right? So let's come to the point here. Coincidentally, I used to teach Dr. Mundzir the subject of photonics. That was a year ago. I thought he wanted to do PhD under me. But based on what they said, do not do under him. He's too strict, they say. So don't ever do a PhD under him. But nevertheless, I still have about 20 PhDs along this direction, almost on the verge of completion. Now, let me come back to Dr. Mundzir. Now, as far as I'm concerned, according to what the supervisor has mentioned, Professor Dr. Noria, he is a cooperative guy in the sense that when we had, I think, the arrangement with Chazan University from Saudi Arabia, where we have another professor coming in to look into research work, they collaborated actively, and I think he has reached to the level of international standing along these lines. Now, coming back to the period when I was chairing the meeting, now again, whatever is being done goes back to Dr. Mundzir. Why I'm saying this? First, when I chair the meeting, I have to chair it accordingly, meaning he has to be at the page whereby he's more relaxed, and he has done that. Second, I should be in control of the Viva session. So before I started the Viva, I have mentioned to the examiners their responsibilities. This is important because they have to know their responsibility. Now, some examiners would just look at what they have read based on the thesis, and they would have a preconceived idea, that's it. There's no more changes. But I think that's not fair, because reading a thesis and hearing from what they have presented plays a crucial role. So for all of you, when you intend to do your presentation, make sure you do the deliverables very, very carefully. The intent has to be clear, the message has to be clear, the contribution has to be shown, and I think that's what Dr. Mundzir did during his Viva. Now, along the way, even though the examiners have given a B1, now after his presentation Q&A, now my task there is actually to moderate the session. Okay, I cannot interfere in the running of the examination, neither the supervisors. I think it's like with Dr. Yaakob Madaud and I think Professor Dr. Sulaiman Wardi from UM. They are the decision maker. My task is to moderate, to ensure that fairness, professionalism is being done throughout the Viva. And at the same time, I think I've told Dr. Mundzir what are his rights as a student. Okay, these rights are important. Okay, in the event you fail, you should know what are your rights. How do you go about appealing whatever it is? Right? This didn't happen to him. So what happened after the examiners have given a B1? So I told the examiners, this is based on what you have read in the thesis. What you need to do now, this decision is not final. You have to see what the candidate has presented. Based on that now, you can either upgrade or downgrade the results. It is at the liberty of the examiners. I think both examiners unanimously accepted that he has done exceptionally well. It's an excellent one. And that's how he was pushed up to A. Meaning, because when you look at his thesis, there were not much mistakes in that. Typographical error is normal. Anyway, nobody is perfect. So, problems are there. That one can be done within less than a day, and he did that. Any questions?
Thank you, Prof. Jalil. Okay, you heard from Prof. Jalil that he got an A. Extraordinary, excellent, right? To the record, from January to today, there are only 5 students get A. That is 0.8% of the total. How many reckon? 509. So we are produced 509 PhD graduates. So he is about 0.8%. 5 candidates that get an A. Meaning that, but he has a good chairman in the Viva when he defends his thesis, right? The chairman knows that the quality of the thesis. But of course, the one really knows what it are the examiners. But chairman facilitate for him to defend his thesis well and to get a good grade. So I would like to really applause to the chairman. Okay. Now let us see the person that say open the door for Dr. Mundzir. That is Dr. Yaakob.
Saya sebagai internal examiner, external Profesor Sumaya. Sebagai Ketua Jadi sekarang memang no error. Masa represent pun cukup bagus. Kita tak boleh nak soal. Tak ada silap, no mistake. Saya bagi B1, external pun bagi B1. Kalau ada correction sikit, sekali kita silap. Sudah, macam bagi dari kita kita meeting dan kita A. Kita mesti membuat. Okay.
So that's a short and sweet. Right? Yes. As you see, just a bit. When you submit your thesis, that usually I will tell my student that when you submit thesis, the thesis should speaks by itself. That I think that's what Dr. Mundzir's thesis is. But elaborated during during the defense. That's the viable say. From that B1 it becomes an A, right? So therefore, not only you wrote it writtenly, verbally written as well, but of course with your verbal communication during your Viva. Okay. Actually, I will talk to Dr. Abdullah to speak, but he said that because after 40 days in Hajj is quite tiring, so he said that I will reserve. But I would say that both our parents are the one that initially mold Dr. Mundzir, right? The one that really formed him, then able to step foot at UTM in 2009, right? Then today, then until tomorrow, 24th, he will be credited with PhD. All right. So with this, we'd like to call upon Dr. Mundzir to speak, to share his experience from not only from during PhD, perhaps during the first day that he entered UTM, why UTM is a place for him. Dr. Mundzir already registered at University Petronas, Technology Petronas, UTP, just one day and come back here, just to pour you on.
Very good morning. It's such a humble moment to speak in front of distinguished audience. We have professors here, the Dean, and the Deputy of Dean, Masih Weather, from the Technology Dean, Prof. Jalil, maybe there are some more professors here, and also associate professor. So I would like to share a couple of things based on my, I think, just little experience that I gained in the past few years. Like, I'm not the best person to talk about this because I'm given a series of opportunities that shorten the time of my study. But in terms of knowledge, itself, and in terms of the understanding, and in terms of experience, I'm not any better than the others. And yeah, I have my friends who graduated with me, but I believe he's much more, have more experience and much more knowledgeable than me. So, what is it? Should I start with the presentation? Or?
Yeah, go ahead.
So today I would like to, I think it's Viva, I think.
Okay, go ahead.
Okay, so this one, I think it's the first time Viva and UTM is being done openly. So it's quite a moment. So my supervisor is Prof. Noria Fidin. She is one of the experts especially in the field of laser in Malaysia. So she has a lot of PhD students. One of them is me, and I think about 30 plus students PhD. And my thesis title is Laser Surface Alloying. Laser surface alloying of aluminium with iron by using switch and gate laser. Characterization and optimization. So it's basically my topic. So introduction. Laser has revolutionized the material manufacturing industry by providing alternatives for processes such as cutting, drilling, marking, engraving, and surface modification. Surface modification particularly is a process that we aim to modify a thin layer surface of a material so that we can improve the surface independent properties of that material. Best example is aluminium. Aluminium poses lightweight, so it is cheap. But the only drawback for aluminium to be used as much as steel that have been used in heavy material, I believe in industry, is because of its poor surface hardness. So by surface modification, we can engineer the surface of aluminium so that we can improve the surface hardness of it, so that it can be used as much as steel. But by this process, we can retain the original properties of aluminium. So it's still light in weight and it's still low cost. So by this process, what of properties can be tailored from the where resistance, we can modify the corrosion resistance, the surface hardness, and weightability and everything. So one of the most promising technique under the category of surface modification is actually laser surface alloying, where we use laser to alloy a surface of materials. So previous work so this is problem statement. Previous work on laser surface alloying, they have I think it's extensively researched area. So they have used different types of laser. They have used different alloying elements, and also they have improved several properties into such a level. So, but the industrial application of this process is surprisingly small. So the reason of this is being researched from my reading, from my literature survey. I found out there are two reasons that are lacking in the process of laser surface deployment. The first is simultaneous optimization of different processing parameters and the predictability of the process, and also I can see from here. And also the second is very limited process monitoring. So if we are to do the process in large scale, we need to have a process monitoring system whereby the processing parameters can be simultaneously fed back into the control system. So these are the two, I think the two reasons that lacking in laser surface deployment. So in my thesis, I'm trying to find a solution for this lacking, for this problem. So the objective of my thesis is actually so the objective is to identify the mechanism, the physics behind the laser deployment process, and by using the switch and the laser, and secondly to be able to monitor the whole process in situ or in the online process, online time. So under this category we have three more sub-objectives. We have to characterize the laser surface deployment with aluminum with ferrum via single exposure, and the dependency of laser energy and also coating thickness. So second is to analyze the plasma emission on alloyed aluminum via LEAP system, laser induced photon spectroscopy, and last to monitor and to optimize the coating thickness in LEAP system. So this is the literature review or survey that I have done before starting my research. So we start from the overview of the laser surface deployment. What is the laser surface deployment? What is the process that I'm going to deal with in my research? The overview, the type of the implementation of laser surface deployment. And secondly is the previous works on the variation of the coating thickness, and so the last is the previous process monitoring and laser surface deployment that have been proposed before. So laser surface deployment, I think it's just brief. I think the time given to me is very short, so I'll just skip this. So this is basically the past research in laser surface deployment in aluminium, especially since 1981. So I read all the papers from 1981 and I write it down in a table. So I divided into which laser that they used, which type of aluminum that they use as a substrate, which alloy element that they're going to introduce into the surface, the material, and also the properties of interest in their study. So this is quite extensively researched area. Until 2014 we have papers, but they are using newer laser and newer alloy element to be embedded in this. So what is lacking based on my reading, so they are lacking a variation of the coating thickness in laser surface deployment process. So previous research they just put the thickness, they set the thickness at certain level and they never varied it. So what I did, I varied the ferrum coating on top of aluminum from 110 micron up to 180 micron by powder spray coating. So this is one of the new things that I try to look into the effect of the coating thickness into the final quality of the environment itself. So process monitoring in laser surface deployment, a few process monitoring that have been proposed in laser surface deployment. It is important to have a process monitoring because in laser surface deployment, all the parameters that we set into the system, we need to have a feedback control system into the original control. So especially for large application, large scale application. So some of them using process control computer system based on fuzzy logic algorithm, and some of them using optimization using X-ray imaging, but this one is very expensive because it has a safety measure because it uses X-ray. And lastly, they develop a simple and low-cost process monitoring by using photodiode. But this one is very simple and less information can be retrieved from that. So this is the research that have been done that uses leads to as a process monitoring system in laser-based processing. So I found that less work have been done actually that applying leads to be as a process monitoring system, especially in laser-based process. So this is the research methodology. I start with the sample preparation, and we have the laser alloying process. And then two kind of observation we are doing. So one of the imaging system, and we have the spectroscopy system. And the last is the that observation where we send the samples for characterization. So this is the laser, the result and discussion. This is the subtopics, but I didn't go into this because it took so long time. So basically it is, firstly I characterize the process and optimize the process based on the physics behind it. So what is the physics behind the what is the interaction? What is the mechanism of interaction of the laser that induce the alloy itself on top of the aluminum? So in the end we have a laser surface alloying process monitoring by using leads. So different process parameters can be simultaneously monitored by using leads. So the conclusion is really quite fast. So we have demonstrated the feasibility of using Q-switch and the laser for laser alloying process. Less work have been done using Q-switch and the laser process because Q-switch and the laser it causes vaporization, and actually it basically in the other process they actually destroy the sample, destruction in the nature. So, but I have managed to use the same laser for alloying process, and then so I've optimized the laser surface alloying process based on the two parameters, which is the coating thickness and also laser energy, and the analysis from the plasma that forms on top of the laser surface region of aluminum is being characterized spectroscopically, and then the information of the process is then combined with the final properties. So I think that's all.
So you agree that this thesis is comprehensive, rigor? If you look at the literature review, he reviewed a plethora, a raft of literatures, right? To the point that he submitted it in 2015, but the latest literature that he did is 2014. Do you think that his literature is recent? Yes. Anybody like to change the topic to physics now? Okay, now we like to open for question and answer, right? So, anybody would like to pose up the first question to Dr. Mundzir? This is a colloquial event, not we like to be as formal as possible. So, anybody like to start? No? Okay, all right, okay. Your name and what is your major now? Okay.
Assalamualaikum. Okay, my name is Sabrina. I'm from Faculty of Management and I'm taking PhD first semester. Alright. Dr. Mundzir, I have questions for you. Right. Would you mind to share with us, okay, since we are junior for you, okay, that how many hours that you block per day for your thesis writing and maybe read and write that you block per day? How many hours? Okay, that is my first question. Right. And question number 2. Just opinion from you. Do we need to prepare a thick proposal to defend our proposal? Okay, that's all. Thank you.
Okay, thank you for the question. The first question, I don't know, I never remember how many hours. And then I think I just devote my time to do whatever I do. So, and I'm studying, so I just, whatever time I got, I try to do my best to fill it with works that I need to be done. And for the second question, I think it is subjective. It does not depend on how thick. You can put all your pictures and then you become. So I think it's subjective, so it depends. But I think thickness doesn't represent the quality of the proposal. It can be very thin with few pages, but it's still comprehensive and it follows the flow that everyone read it, that they can see the flow of the work that you're going to do.
I think, can I end?
Yeah.
All right.
Okay.
Very interesting question. But again, you have to bear in mind, whatever you do, you have to have the love for it. You have to be passionate about it. So you shouldn't block the number of hours a day. That's one. Second thing, when you are talking about the writing up, you must bear in mind that when you are doing your PhD, certain things have to be done concurrently, simultaneously. For example, sometimes you may want to do some literature search. Once you have done the literature search, then you got to analyze. In between, you say, I'm tired about this. So you go back and look at your first chapter, see what you can do. Or those who are doing the experiments, they can go back to the methodology side and so on below. So you shouldn't block the number of hours. Sometimes, in the wee hours of the morning, you may wake up and say, hey, I need to do that. I believe he has done that. Now, coming back to your second question about the thickness, I think SPS has already mandated that the number of pages to be given is X numbers. So meaning you shouldn't go there. But again, that is the maximum because certain students are very good in their writing up. So what you can do, normally when I teach students, I would tell them that in any examination, if you write too much, sorry, don't quote me, if you write too much, it is inversely proportional to the marks. So what you need to do when you're doing your writing up, it has to be short, sweet, precise, succinct, but the intent of the message has to be there. Then that should be fine. You should be happy with yourself. Thank you.
Can I add to that? Let me tell one short story here. I met a student when I did my short sabbatical in Hiroshima University, Japan. One lady, PhD lady, in the second semester from Beijing, would like to go back for Chinese New Year in February. This supervisor said that, how long are you going to go back? 2 weeks, sensei. No, you have only 1 week. Go and change your ticket. She came to see me. She thought that I'm a Chinese from Japan, not from China. So I said, so what can I do for you? Can you advise me to tell what I'm going to tell my sensei so that I can get that 2 weeks? The sensei stuck to his gun. No, you only have 1 week. Then he changed his ticket. Right. What I'm trying to say here is that I think commitment, passion, what mentioned by Prof. Jalil is one thing. Yeah. I would say to my student that 8 hours a day, 5 days a week, right? Because PhD is your baby. Yeah. You need to see it as your baby, right? And if you are already married and you have your own real baby, when after the office hours, then the other baby is at home, right? I think that is the thing. But if you were to look further on how Japanese sensei supervise their students, that you must come to the lab before he arrived, and you must leave the lab after he left, right? If we do that in UK, each and everybody I think will graduate on time, right? Okay, now next question.
Good morning, everyone. My name is Christina from Faculty of Education. My question is about what is the major problem you faced in your studies and how did you overcome it?
Major, thank you for the question. What is it? Problem? Major problem. What is it? But I can relate to this. When I start doing my PhD, I face some problem, which is Actually, I didn't like to read actually. So most of the time I learn by listening, and I think YouTube is the best teacher. No, at home, okay. We have lecturer, very brilliant lecturer in the class. So when I start doing PhD, I need to read books, journals, and also what is the thesis. So I need to change how the way I learn. It's quite difficult for me actually in the first place. I need to read journals. Sometimes I read journals and I never understand anything. And then that's it.
Yeah.
Yeah, for my problem, I think just to need to like reading, start to read, and at one point you will like what you do. So do whatever you need to do.
Those who are in the first and second semester, do you feel that you get confused and you get worried? Yes, you need to get worried. If you get worried, you're on the right track because your supervisor doesn't have to worry for you. It's important to know that, right? Okay, next question. Yep.
Assalamualaikum.
Assalamualaikum.
My name is Shamsul from MJIIT.
Okay.
Just simple question. If you don't mind, may I know how many publications did you publish before submitting the thesis?
Publication. So because I involved in a lot of research projects, so it is not confined within my scope of area only. So I think I managed to publish. I think the maximum is 20 from total.
Okay, thank you. My name is David from Chemical Engineering, Masters. I want to ask, if you don't mind, can you show us your result and how it compares to the latest literature, 2014? And why did you decide to do your PhD?
Start with the result, is it? But I didn't put any result in my slide here. So basically it is because my process is relatively new. So I think no one, from my reading, no one else has done it. So I couldn't compare with the other results unless it is, but this, if I compare with the continuous wave laser mode, so it's completely a different treatment. So the modification has been done on the continuous wave mode is different, so I couldn't compare it. So the second question is, what motivates me to do PhD? Is it? The first question is easier than the second question. I think is I like to learn physics. So since my school age, I love physics. So I'm very passionate about physics. So after I finish my bachelor degree, I didn't think about working. I just continue to PhD. So.
All right. More question?
Okay.
Assalamualaikum.
Salam.
Congratulations and Mabruk. I'm not a
Thank you.
student and I'm a member of the public. I got to know about this from UTM page. I've left academic world years ago after completing my degree, and I've left the working world also years ago. So now I'm a full-time housewife.
Okay.
And I'm homeschooling my kids. So I just want to know, finishing, I mean, you already finished this PhD. So what is your plan for the future? Because you're going to enter the real world.
Okay.
So what do you plan to contribute to the Ummah? And also, how do you see yourself in, let's say, in 20 years' time? I believe that you have a vision, right?
Yeah.
Yeah.
So, okay, thank you. So basically in 20 years, my beard become longer. And so my contribution, is it the question? My contribution. So I found that the physics, the science actually in the Ummah is not strong enough as compared to the one that is leading right now, which is, I believe it is in physics UK. So physics in the world is driven by mostly in UK. So the frontier of the knowledge in physics is with the West. So and I found that less students actually, based on my observation, less students like physics. I think physics is, they think it's physics is very difficult, or they don't like it basically. So what UK did is actually they have they call it science popularizer. So there's one professor named Brian Cox. He's very well, he's a brilliant professor, 40 years of age, and what he did is he promotes physics, science, and particularly in physics because he's an atheist. He is a particular physicist, yeah. So what he did, he toured all around the UK to give the mass, to give the people to know about physics and try to induce love of physics into them. So, and he's being invited into BBC program, so they have a lot of program under him. So basically because of him, all physics courses, all science courses in UK is become full. So students nowadays, I think in recent years, they're trying to do physics and science basically. So I think, so the answers, my contribution, I will be, inshallah, I try to motivate people to know about this field. Because I believe physics is a very important field, because physics lays the foundation for all the engineering concept. So all the engineering concept built upon the physics concept and physics theory. So it's very important.
Before that, just now I talked a bit with Dr. Mundzir. I'd like to share with you all that I just share with him that I visited Institute for Physics and Mathematics of the University at Institute of Tokyo. In the list, that institute looking just on theoretical physics, not experimental physics. In the list of all those researchers, including Nobel laureates and top-notch postdoctoral, none are from this Southeast Asian country. No from Malaysia. None of them, well, this one about Umar just now, none of them the name begin with Muhammad. So I told Mundzir that perhaps you'll be one of them in the list soon. Yeah. Okay, next question.
Thank you.
Yeah.
I am Yasir Zahidi from the Faculty of Electrical Engineering. Excuse me, I want to return back about the results that when you talked about. And you said that your research was, your method is new, so you couldn't compare with the others in the literature, something like that. So that means your comparison was based on the experimental results, let's say, to convince the Viva, because the other thing is that did the Viva, the panel, the Viva, of course, they focused on the comparison. So how did you convince them, for example, showing them the literature review one by one that this is different and my method is new, so I focus just on the experimental comparison? Thank you.
So to answer your question, before I doing my experiment, I have done slide, I think it's it's not very complex simulation, but it's still simulation to predict the interaction of the laser that I incident on the sample. So it's basically that is the foundation. So after I did that simulation, so basic simulation basically. So I continue with my research. So actually I can compare with, I have done simple comparison with other technique, but because I'm focusing more towards the physics itself. So because we are from the Faculty of Science, we are focusing on the fundamental process behind it. So from engineering, maybe perhaps they compare with different techniques, so they want to get better result. So but physics, we are laying the foundation, the knowledge itself for others to build upon it, the technique. So especially the physics behind the resistance of that.
Okay. More question?
Let me just
Yeah, okay.
edit a little bit
Abdullah.
your questions now. Anyway, in response to your question just now, normally when they're doing physics, he has already mentioned that he has done a little bit of simulation. He will compare with that. At the same time, he will look into the past literature, and then he will use that as a preamble. It's a prelude to what he has done, and then he could verify. In physics, you need to verify. And either when you do experimental or simulation, there must be some form of a gold standard. And I think he has done that. Without that, I don't think so the examiners would have passed it. Thank you.
Any more question?
This is a comment from Dr. Mundzir's father. I'm also a doctor in electrical field. Well, comparing the techniques is one of the methods we compare his research. The other way is we compare the results. What is the result of his technique that he used? Compare the result from the other methods. The process, we don't compare the process, but we compare the result itself. How about comparing result? This is my question to my son. How do you compare the result of yours?
This is the hardest question ever. So how do I compare? So basically based on what I read from my reading. So I know this process, what is the result that comes out from that specific parameters that they apply. So we have different process. So what's the result? So basically it's all different because they are all focusing on different aspect of that treatment. So comparison can be done only if the same the same parameters of interest with what I'm doing. So not many that I found in literature that doing the same as me. So with the list that I've shown, there's some of them doing the process monitoring. So some of them not much really. It's 4 or 3 that I've